Welcome to Elixir Wizards, a podcast brought to you by Smart Logic, a custom web and mobile development shop based in Baltimore, Maryland. My name is Justice Epen, and as usual, I will be your host. I'm also joined by my amazing co-host, Mr. Eric Ostrich. Say hi, Eric.
Hello.
And this season, if you've been tuned in, you know that we've been talking about working with Elixir. And today we're going to be focused primarily on performance and training with none other than Devon Estes.
Howdy.
So Devon, super glad to have you on the show. I want to jump in with a little bit about how we met because we have been doing this podcast now, I think actually for exactly 1 year, like today. Our first episode, I believe, went out in the first week of February last year. And it's been a really great year. And we recently started asking on the show for engagement. We want people to reach out to us on Twitters, et cetera. And you emailed us, and because we had asked, are there any open source projects that Smart Logic could support or should support in the Elixir world? And you reached out to us. And could you tell the audience the idea that you reached out to us with?
So one thing that I think would be a really great addition to the Elixir open source ecosystem is essentially like a version of pandas, the Python data analysis and visualization library, because it's a super common thing that a lot of people have to do all the time for their jobs. But the way that Elixir manages the transformation of data, which is really what people are doing when they're solving these sorts of problems, is they have some data that they need to, change the shape of and basically do various forms of maps and reduces over until they get some answer to their question, or until they generate some sort of graph or chart that they can present back to business people to answer their question. So Elixir seems like just the ergonomics of the language and the semantics and the syntax in the language seem to fit that problem really well. And also that's typically a problem that can be very easily parallelized in terms of doing the computation. So the fact that Elixir does have, and the Beam has that effortless parallelization plus the ergonomics and the semantics of the language. And then also now that we have something like Scenic where we can generate really great charts and graphs natively and with all sorts of customization, it seems like the pieces are there, but then it's a massive amount of work to actually build out something like pandas. I mean, this is a library that has taken probably dozens of people, dozens of years to build up and to optimize. Like, luckily, a lot of that stuff just ends up calling C. So like we could rely on a lot of that as well. But it's just a whole lot of work. So if someone were to do it, it would really need, it's not something that an individual could reasonably do. It's something that a company or some sort of group would need to support if they were going to do something like that, because it's a huge undertaking. And that's probably why it hasn't been done before, because it is such a big thing. And there is already pandas that exist. People say, like, why am I going to spend years of my life building a better version of pandas? And well, like, because it will be better and because it will be used and because it'll be worth it in the end, but it's a big investment. So that's why I thought if there was a company that wanted to support it, that would be a really great addition to the community because it fits super well.
I love this idea. I have a little bit of experience with pandas, and I distinctly remember this aha moment when you're starting to play with tabular data in pandas and you're just like, whoa, I wish I had something like this at the time I was thinking Ruby, but now in Elixir as well. How did you discover pandas? What's your experience? How do you know about that?
So since 2012, I've been a freelancer, and that changed somewhat recently. I'm sure we'll talk about that more. But one of my previous clients had a team of data analysts, and their job was basically this was a nonprofit, and the nonprofit's basically whole existence was to collect and analyze data. And these data analysts basically did their analysis in one of two ways. One was like massive SQL files that I would help them write. And then the other was with stuff like pandas and Python data analysis and visualization libraries. So that was my first exposure to it back in 2015. I mean, I knew a little bit of Python before that, and I knew it was a thing, but I hadn't really seen people work with it in earnest until then, back in 2015. And then my last client before I started my new job in January was Klarna, which is a bank here in Europe. But the team that I was on had a data scientist on it that was brilliant data, like proper data scientist, but he used all of that Python stuff for his data analysis and the ML training stuff that he did as part of his job. But I showed him a little bit of Elixir. He's like, yeah, this is really cool. I have all of my things in Python. Like, this is what I use because all of my tools are in it. So it was almost like he didn't dislike Python, but he definitely knew, like, this is the thing that I use because all of my tools are in it. I have to use this. There are no options for those people right now because they rely on those tools so heavily to do just about all of their work. So it would be great to give them some options, because I do think that it would make their lives a whole lot easier, because like there were quite a few times when I had to write shell scripts to basically manually at the process level split some files so that he could like run 8 or however many cores he had on his machine. I think at one point he was running it on an AWS box because he needed to do it faster in parallel. So he was running on an AWS box with 32 cores, and I wrote him a bash script to split basically this input file into 32 chunks so that it could be done in 32 Python processes, and then in another process basically reduced back together. So like, why do that when we have the Beam? Like, it would be so much easier for everybody.
Yeah, that definitely sounds exactly like something that Elixir would be great at. So you hinted a bit at this a little bit ago. So where are you now?
Yeah, so the beginning of January, I started at Sketch, which is, some people may know, as an app that began just as a Mac app for designers, basically to help them make designs. It's actually a really old application. It's like 10 years old. But starting last year, they started with a beta of doing Sketch Cloud. So basically collaborative stuff. That's where they're going. So they have the Mac app, which is still a thing, still a big thing, but not everybody's on Macs. I personally am not on a Mac. So now you can use Sketch in the browser, and pretty soon they will be able to collaborate. So basically live real-time collaboration on documents. So designers, developers can work together at the same time on a document, doing all of that sort of stuff that you would expect with live real-time collaboration, of figuring out how to resolve conflicts and edits and stuff. That's the end goal. But right now we're just working on, actually just yesterday, they took Sketch Cloud out of beta and launched a big new feature, their developer handoff feature. So now after the designer is done, developers can go and get all of the information that they need to actually translate these designs into front-end web applications. So getting the CSS and the font sizes and all of the spacings, all of the fonts, all of the information. And pretty soon we'll be able to export assets as well. So developers can go in, and instead of having to ask the designer, like, hey, can you export all those icons for me? They can just go into Sketch Cloud and get all that they need to do their actual implementation of the design. So that's where Sketch is going. And behind that is an Elixir application that is right now serving as the backend for a lot of that, the backend for Sketch Cloud and also for the Mac app. And they're in the process of pulling all that stuff together. And hopefully this year we'll be able to get a lot of it up and running. They did an MVP of it first, and just did a pretty quick like proof of concept and got some people in the beta, and it turned out that everybody liked it. And now we're taking the sort of hastily done MVP and actually making it nice, and also adding all those other features. And yeah.
I'm really surprised to hear you say that Sketch is an old application. I remember getting Sketch like when it was in beta, and this was probably now 6 or 7 years ago, which when you get something in beta, it feels new, even when, 7 years later, you have had to get new licenses and everything. So that's pretty interesting. Klarna, I did not know you worked at Klarna.
Well,
I've used Klarna.
Yeah, they're in the US.
To finance. Go ahead, sorry.
Yeah, they're in the US now too. I mean, I did a so like I said, I was a consultant. So I was only there for like 8 months, because they have pretty recently opened their next big engineering office here in Berlin. And they, as a part of that, are just trying to hire as many developers as they can here in Berlin as possible, because they have their main office in Stockholm. And then they're, by the time I got there, they'd been open for a little over a year, and they had a little over 240 developers that they had hired in a year. So they're building up all these teams and training them up. But when you're hiring that fast, what happens is inevitably so for example, the team that I was on, Klarna is a sort of famous for being a very old Erlang application. That's another one that was about 10 years old. And the team that they had hired was 4 developers. And they said, like, okay, here's your application. It's Erlang. And none of them had written Erlang before. And so they're like, okay, this isn't so good. Let's see if we can hire someone that kind of knows this stuff to help train them up and get them used to it. And so that's what I did. I was with them for a bit, helping their team get up and running and helping with the development of that application. And frankly, a lot of that work was scaling and performance tuning, because that part of that application, because they had now sort of split these, what used to be one huge monolith out into some smaller services that each team owns individually, because they're actually a company where microservices is a good fit, because you can't have, well, you can, but it's really hard to have like 700 developers all working on one repo. So this application that they were working on was basically like the bottom of the stack of Klarna. Like we had no dependencies. We were everyone's dependency, and we had no dependencies on any other team. But because of that, everyone called us, and they needed extremely consistent and extremely fast performance. So a lot of it was figuring out like how can we, and again, at Klarna's scale, even if you're just looking at the P99, that's kind of not enough, because 1% of a couple thousand transactions per second is still a lot of money you're leaving on the table. There's one bug that we found when I was there, when they did the analysis, like the analysis of the cost of the bug gets measured in like millions of euro. So getting it right and getting it fast, and especially the part of the service that we were working on was like one of the core things to how Klarna works. And if it doesn't work, we made an improvement just in the Netherlands into how our thing works, just for one market. And again, it was like the benefit to Klarna was measured in like the thousands of euro per hour just for one relatively small market.
Yeah.
So it was a really important part of their application, and that team was like, we feel really scared because we don't know Erlang, and this is super important. So can we have a consultant? So yeah, I did that for a while, for about 8 months.
Yeah, I want to talk a little bit about Klarna because this is new. It's coming up, and it's a good digression. I actually used Klarna for financing a one wheel for my nephew, and it was a great experience, very smooth. And I think later I found out that are they the fastest growing European financial technology company like of all time or something crazy like that?
I don't know about fastest. I know while I was with them, they announced a big round of funding, and that put them over like the biggest privately held. They said like the biggest fintech company in Europe. So I think that with that round of funding, that put them over like $5 billion valuation or something, or 5 billion euro valuation. So, and like when I was there, they also had rolled out they've just gotten ready. I think this month they started rolling out in Australia, and they're always rolling out in new markets and more vendors and more, they're doing more in person, and they have a credit card now. So there's Klarna card and all kinds of, like, they're always adding more stuff. But at the core of all of this stuff was that one service. And that's why it was.
Can you dive more into sort of like the service and optimizing Erlang for performance? I think I'd love to hear sort of feel free to dive deep and get as technical as you want.
Yeah.
Our audience loves that kind of conversation.
Cool. So yeah, while I was there, basically the problems that we were looking at, the median latencies were always fine. Median latency was always sub 40 milliseconds. And this service, one of the hardest parts of doing that sort of work is actually just finding out what your requirements are. When I first started, I was asking, I was like, so what are the requirements? And they said, well, the P99 needs to be under 200 milliseconds. And I said, well, that's not a metric. P99 is not a metric. P99 is a metric over a period of time. Are we talking the P99 over 1 second or 1 hour or 6 hours or 24 hours?
What is P99?
P99 is the 99th percentile of requests. So you can say like the P50, that's your median, P95, 99, 99.9, all the way up as far as you want to go. Because when you're looking at analyzing the performance of an application, looking at median is usually a really bad idea. What you really want to look at is the tail. Because if your application has a median latency of 50 milliseconds, but 5% of your users have a latency of 1,000 milliseconds, especially at Klarna's scale, 5% of users is a lot of users. Like you really can't afford to be leaving that amount of money on the table or giving that many users a bad experience, because they're not going to continue to use the service or the application. So when you're doing that sort of optimization, you're really looking at P95 and up. And for Klarna, we were mostly looking at P99. And just getting people to agree on what the parameters of the service are. Like, what is the maximum latency that we're allowed? What's the P99 over what time frame? The maximum latency over what time frame? Those were basically the two biggies. And there were issues where they would see somewhat randomly, like the median latency, 50 milliseconds. P99 would usually be around 180, which was still a little too slow. But randomly, they would get sort of these spikes where they would have the P99 jump up to like 1 second or even 1.5 seconds. And they would see the max latency go up to like 5 seconds, like the database was timing out on requests. And of course, the database is almost always the problem in most applications. And that was the case here. But basically what was happening was the data that they had was growing so fast. And the only way that they could efficiently query the data, because they needed to do a lot of queries, basically, if they see a customer named like John Smith and they need to try and decide, have we dealt with this customer before? Because one of the big things with Klarna is you don't have a login and username. They just sort of know who you are. So they're trying to decide if we have seen this person before, and that involves doing a pretty significant search through a pretty significant amount of data. And basically what we learned was anytime we actually have to hit disk, we're not going to make it in time. So what we had to do is just get bigger database boxes. Like, you can just keep everything in memory all the time. Once that Postgres cache is warm, you're golden. And that's the spikes you were seeing, is when a customer hadn't been there for a long time, their data wasn't in cache, or when someone else on that page hadn't been seen in a long time, then they weren't in the Postgres cache. And then they actually had to go to disk. And even though it was hitting an index, the index was still big. These were indexes that were 80 gigabytes for an index, and they needed to do several index scans on pretty big indexes. And if they had to go to disk for that index, even though it was an index, when you're dealing with indexes that are 80 gigabytes, just paging through a solid state disk is still going to be too slow. So it just had to be keep everything in memory all the time, and then you're golden. So just buy bigger database boxes. And luckily you can do that pretty easily on AWS, and just, click up to the next level, and all your problems are solved, and all your tail latencies go back down to a great level, and everyone's happy again. But the time spent in the application is literally 2 milliseconds out of that 50 or however much. That was consistent across every request when we instrumented it. The time spent in application was never more than 2 or 3 milliseconds. All of the time spent was in the database. And that's a really common thing. The database, when you're looking at performance, is almost always the problem.
Does Sketch have the Sketch Cloud, does that have any unique performance constraints, kind of similar to what Klarna had?
It is unique. It's the first time that I have ever been memory constrained on an application. So one of the things with Sketch Cloud is we are storing and versioning your files. So if you're doing a design of something, we are keeping that design and versioning it, and there's nothing stopping someone from sending us functionally infinite file. So they have some image that is, so just today we saw there's a proprietary JSON format for a Sketch document that basically stores all of the schema for a Sketch document. And these are normally, 4-6 megabytes. And we're seeing some today, because like I said, we just launched that new feature yesterday. So there's a lot more people in Sketch Cloud today doing this kind of stuff. And we saw some that were like 150, 200 megabytes. And we saw a couple instances that were starting to run out of memory, because if we have too many of those people basically uploading these documents to the same node at the same time, you can see pretty big jumps in memory consumption. And so this is a problem. This is something I've never had to deal with before. It will be very fun to deal with. I mean, luckily we're in the process of actually changing how we ship basically these changes in a document, like how we do the versioning. So instead of always sending the whole document, we're going to start just sending diffs, sort of like Git. So like this will hopefully become less of a problem as we move towards that new way of tracking changes and doing versioning. But for now, like, we get a lot of documents from a lot of people, and some of them are really, really big. And in order for us to sort of do what we need to do, because there's always all this processing that happens anytime we get a document, we have to kick off a whole lot of processing of these things to like pull out layers separately and all kinds of stuff, pull out certain assets. So there's this whole other background service that runs anytime we get that. And yeah, memory has been the problem. It's something that I've never experienced before, because typically you're not dealing with people sending you huge files that you actually need to process in memory. Like usually if you're dealing with that sort of upload, you just have the upload stream directly to S3 or something. It never really hits your server. You don't have to deal with it, but because we need to process it, we actually need to receive the file. And so that's interesting. It's definitely an interesting problem. And I would say it's unique. First time in my last 8 years that I've been memory constrained like this on an application that hasn't just been a normal part of like when I used to have Rails apps that some people would just instantiate the world from database queries. Like that would be a problem, but this is a different version of that,
Yeah, one of the nice things of switching from Ruby to Elixir, like I remember the first time I saw a Heroku graph of like memory, and it was like just a stable like 100 megs, and it was like, this is weird.
Yeah. That's why when I even saw this graph yesterday, there was one graph that I saw, and the running, like the stable state of this application was a little over 2 gigs of memory usage. And the first thing I said is like, there's something else running on this box, right? And they're like, nope, just us. And then a little bit after, there was a 1 gigabyte jump. And I was like, what's that? And they're like, people using the app. And I was like, I've never seen this before. I have no idea what we're going to do, but we're going to have to figure this out. So it's at the moment still an unsolved problem, but it's definitely a unique performance optimization that we have to deal with.
So moving on, can you tell us a little bit about Benchee? What is it? How might someone use it?
Sure. So Benchee is a benchmarking library. I think it's one of the best ones, but I am a little biased. Basically, so one of the important things, it's for Elixir and Erlang. We've designed it in such a way, there's no macros, there's nothing that you can't use from Erlang, which is pretty important to us. We even have like a regular Erlang module if you want to use it with like the Erlang module style instead of the Elixir module style. But it is a benchmarking library that allows you to do micro or macro benchmarks. It's pretty fully featured. There's hooks, there's memory usage benchmarking, there's all kinds of stuff that you can do for inputs. There's something I'm working on now, which is reduction counting, which I'm pretty excited by.
What is reduction counting?
So the reduction you can think of as a unit of operation, a unit of work on the beam. A reduction in the purer mathematical sense is when you have a function inside a function and you evaluate one of those functions. That's one reduction. All of our stuff is just functions, and functions get evaluated, they get called. And every time a function is evaluated, that's one reduction. And when the scheduler is managing all of the different processes, what it's doing is it's counting reductions in a process and saying, okay, you've done 4,000 reductions, or however many people configure their VM to be. They say you've done a fair amount of work, and then you go back to the back of the queue, and then the next process does another 4,000 reductions. So it's consistent. And a reduction is a consistent unit of operation, consistent unit of work that is always the same in any architecture. So depending on the word size and depending on your architecture, different functions may have a different number of reductions that they require in order to be performed, because it's like at a very, very low level. But these reductions are a great way to actually accurately judge how much work is being done by a function, rather than just looking at wall clock time, because wall clock time is notoriously unreliable. Whereas measuring functions is exact. If you benchmark the same function and it's a pure function, then you're always going to get the same number of reductions back as long as you're on the same architecture and the same machine, same word size, same architecture. You're on the same benchmark, you will always get back the same number of reductions. Of course, there's variation in that between architectures and between machines. So if you're on x86 or ARM, or if you're on 32-bit Linux or 64-bit Linux, then you'll get variations, but it will always be consistent per architecture. So this is one way that people can do essentially performance testing, like accurate performance testing. And that's really why I'm excited by it, because typically when I see people that try and do performance testing, they say like, expect this function to take less than this amount of time. And that is functionally useless, because time doesn't actually test what is going on there. Time could be a factor of, if you're on a shared CI box, if you have a busy neighbor, then that time is going to go up, or it will just be wildly unreliable to where you need to have the margin of error so high that you're not actually testing anything. Whereas if you're testing reductions, and that reductions for some extremely crucial part of your application never go above a certain level, then you can make sure that at a pure mathematical sense, that this is not requiring more operations to finish than we need. And that assuming in a steady state where an operation takes a set amount of time and that those are consistent, which is, again, not always true. But this is still the best way that you can actually do performance testing of something and to ensure that if you do have some really crucial path in your application, like the hottest path in your code that is extremely time sensitive and maybe also like really complex, and you need to make sure that this doesn't accidentally go from like a log n to like an n squared complexity because somebody messed something up, and that would have like real implications for your users. This would be a good way to ensure that, is to use reduction counting. So that's something that is hopefully going to come soon. I mean, I've got a PR up and it's like nearly done, but we need to do a little bit more work on the integration with the formatters and stuff. But the actual implementation of doing the reduction counting is pretty easy. The Beam gives all of that to you like super easily. You have access to all that stuff. So it's just a matter of setting a tracer on a process and saying, how many reductions did you start with? And then do your thing. How many reductions did you finish with? Do a little math. Bada boom, bada bing. You got your number. Now that also, there is some caveats to that, of course, which is we're only counting the reductions within a single process. So if you're doing larger benchmarks, right now, we're not going to count like the reductions that take place in some process that you spawn. Of course, if there's any NIFs, we have absolutely no insight into that. So, and that is the same thing for the memory benchmarking as well. So it's only within a single process. We can't at the moment, because there are functionally, when you're planning a feature like this, you have to assume that there are an infinite number of processes doing an infinite amount of work, and you can't assign any change in memory to the thing that you're actually benchmarking because you don't know what else is happening in the VM. The great thing about Beam is that there's that, but the hard thing is actually deciding, like, is this function that I'm trying to benchmark responsible for these other things that I'm seeing? There's no way to tell unless you're doing that measurement within a single process. We're hoping one day to add some ability to sort of like register additional processes to watch. That's something we spoke about with Michał Moskawa a bit because he wanted to do memory benchmarking on Ecto, and Ecto has its repo, which is a separate process. I think there are like 2 or 3 separate processes in Ecto. So like we would need to add those to the count and then somehow coordinate the beginning of the count. So like that is a very difficult thing to do. We would like to try and do it one day. It's something I would really love to do because the reason I wanted to add the memory benchmarking was for the nerves folks, because like a lot of those folks are operating in extremely memory constrained environments, and being able to know how much memory your function is using is going to be really important for them. So probably more so than most other applications. But as that becomes a bigger part of the Elixir community, and I think it's a part of the community that has a great future, I would love to try and build out what tooling we can to help support them in their work.
About how much of your time do you typically spend optimizing for performance?
It varies from client to client. So like at Klarna, I was doing almost all performance optimization, but the client that I had before that, it was none, because it was a brand new company and they were just trying to get up and running. Like they had a really great team actually, and just trying to get their product to market and get an MVP out and like do that sort of early fast iteration cycle as quickly as possible. And so performance was like is it good enough thing? Like, can it be used? Great. Whereas for some of these more mature companies, that's where they need to start looking at what is our like P99.99 latency in this one market and optimizing really specifically for that. So it always is varied. One thing that I do a lot of sort of performance optimization for is the development experience itself. So making sure compile times are fast and test suites run fast. And we have that, to me, is always one of those like force multipliers. If the dev team can move quickly because their tools are well optimized and their setup is well optimized, then everything else is going to move quickly. So,
and I assume that you're using Benchee for the benchmarking.
For benchmarking, yeah, but the benchmarking is actually the second step. The first step is profiling. And there are also luckily great profilers. There's like 3 built into the Beam, I think. And then there's...
Can you explain the difference for someone like me?
Sure. So if a business person comes to you and says, this is slow, you say, okay, great. What is slow about it? And that is profiling. So that is when you basically capture how long you spend in each function while executing a larger function, because functions are made of functions, which are made of more functions and more functions all the way down. So what you're doing is you're getting a log basically of how much time each step in the process took, and then you can see which step is slow. So once you've profiled and you see, okay, so we have that one function is taking like 50% of our time. Can we try and make that one function faster? So you look at that and you write a benchmark for that function. And then you might write a second implementation of that function. And you can test the two and see which is faster or slower. And then eventually you can say, oh, our new implementation is 40% faster than the old one. So we can use that one. But unless you're actually benchmarking, you don't know. So that's the important thing, is you need to be able to benchmark those things in comparison against the same input on the same machine and have a good test. Otherwise, you're just guessing. Like if you don't have data, then it's just your guess. It's an opinion, a hypothesis at best, but you don't actually know.
Go into this. What is the difference between a fact and an opinion?
A fact has data. Science is like it goes all the way back to Isaac Newton and like the famous nullus in verba saying. It's Latin for don't take anyone on their word. So it doesn't matter if some graybeard that's been writing software for the last 50 years says this is the best way to do it. What matters is if there's data behind it. Otherwise, it is at best someone's hypothesis and probably just their opinion. And opinions aren't true. Truth has data behind it. And that's one of the reasons I love benchmarking, is because we have data. We can see this function is faster than this function.
Can I ask you something?
Yeah.
Is there a difference then between opinions and preferences?
Not really. To me, an opinion and a preference is just about the same. And it doesn't necessarily mean that someone's opinion might be wrong. We just don't know.
Okay. See, to me, that's the distinction, right? Is that a preference cannot be incorrect, but an opinion can be wrong. Like if I have the opinion that 2 + 2 = 5, I'm just wrong, right? But if I have the preference for 2 + 2 = 5, there's nothing wrong about that. It's just dumb, right?
So there's a funny thing about truth, though, because truth is constrained to time again. So
truth is constrained to time.
Yes.
Oh man, we could do an epistemology podcast real quick.
I know.
But tell me more about that. I've never heard this idea.
Well, so right now we can say that there are 7 continents, and that is a fact. There are 7 continents on the Earth.
Mm-hmm.
But that did not used to be a fact.
Okay.
It changes.
Mm-hmm.
Right?
Yep.
Because right now there are absolutely 7 continents.
Okay.
There are, the globe is in a certain configuration.
Okay. So what you really mean to say is that truth claims are time bound.
Yes. So it's for any given time, right? Yeah. Same thing with computers. If I run a benchmark and an EMP hits at that time, I'm going to get very different numbers than if I run that benchmark at a different time. Like if there's a solar flare that like absolutely messes with my CPU or something, I'm going to get really different numbers. That number is a very specific thing. And we can only do our best to try and find that. But luckily, like for most things, the time holds truth holds fairly consistent on human timescales most of the time.
So do you make a distinction between truth and truth claims?
Yeah. And someone says something is better. Okay. So like it's one of my favorite things I like to do to mess with people. If someone says something is better, I say, well, how much better is it? Is it 70% better or 40% better? And they say, well, I don't know. I was like, well, if you don't know, then how do you know it's better? If you don't know how much better it is it 1% better? Could it be minus 1% better? Are you sure? Because no one can ever answer that. You can only answer things like
minus 1% better would be worse.
Exactly. If you don't know how much better it is, then you don't know that it's better.
Yeah.
You might be able to say something is faster. You might be able to say something has fewer lines of code. Those are things that you can say, but you can't say something is better. You also can't say something is more readable. You can't say something is less complex unless you all agree on a measure of complexity. Like these are things that people can say. So again, like readability is one of those things that, and someone's like, I think this is categorically more readable. And I say like, yeah, but there are also 1 billion people in China that think that their alphabet is categorically more readable than ours. And we probably disagree because we're not exposed to that alphabet. Like we can't read it.
But that's not entirely true, right? Because there is obviously sometimes when something is just poorly written.
To you, again, it is impossible to know that someone else might not find that better.
Okay. I did have a question about Benchee. Our audience loves to know about like libraries and how people, first of all, like come up with the idea. But then when you first came up with the idea for Benchee, how did you go about deconstructing this problem into steps that you can deal with independently of one another and sort of, create like a foundation for the library? Can you talk a little bit about your process there and your thinking behind?
So it's very important to note that I did not start Benchee.
Okay.
Yeah, my friend Tobias Pfeiffer, Toby, here in Berlin, actually started it. And that's because a benchmarking library is his like hello world for a new language. And he was learning Elixir. And so he wrote a benchmarking library. It's like a thing that he does when he's learning a language. And I used Benchee for the first time back in 2016, I think. And then I started helping with it. And we've done a lot of work since then and got it up to 1.0 last year. And it's sort of become like, I think after most of the core team started using it. And I think like Jose mentioned it in the Adopting Elixir book. We were like, oh, wow. So I guess this has become like the thing that people use now. But basically what we try and do is we first try to get the basics really, really solid and get the domain concepts down really solid. That was one of the first big things that we worked on together, I think back in 2017, was sort of overhauling the domain concepts. So we have in the application now, there's a concept of what is a benchmark and a benchmarking scenario and how do those two things relate, and then a whole suite of benchmarks, because a scenario is a combination of a benchmark and an input, because we allow you to have inputs, and inputs are actually a really important part of writing a good benchmark. So just really nailing down those foundational concepts of the domain was the first big thing. And then following that, we basically looked at what we felt would be 1.0, which was basically once we had memory management, because that was the first thing that was a little bit outside of the core. And if we felt that whatever changes we need to make to handle that were in, that we should be able to functionally handle anything else that we feel might be coming in the future without having to make breaking changes. We love the stability of the Elixir ecosystem. And once we hit 1.0, we really don't want to go to 2.0. But now we feel that the API can handle anything we can throw at it in the future. It is sufficiently flexible enough to add things like reduction counting. And another thing we want to add at one point is a tighter integration with either stream data or the generators from Proper, so that you can do sort of like discovery benchmarking. We don't even know what to call it yet, but basically it's a like fuzz benchmark something, so that you're giving it random inputs and seeing if you have outliers, seeing what the distribution of benchmark times are, so that you can sort of get a feel for the performance characteristics of your application or of your specific function without having like real production data behind it, because it's really, you can't benchmark in production at a micro level. But to be able to try and use random data to reproduce and use those generators to reproduce some distribution of data. So we want to get more into that too, but we basically first wanted to get the core really good so that we could release a 1.0 without having to make a change and go to 2.0. And then following that, we're just picking features where we can. And Toby and I are both pretty busy, but after production counting, there's, the next thing I would love to do is move on to that integration with stream data or some other sort of property-based generator and see what we can do there, because I think that would be another thing that would be super helpful and super cool for the community. And I actually don't know of another benchmarking tool in any other language that has something like that. So I think that might be a unique thing for us, which would be great.
Yeah, before we move on though, I just want to point out my big contribution to Benchee is to discover this issue 313, which is the Mac OS on Erlang has a strange monatomic time. So that's the...
Yeah. So one thing we wanted to do is, there's always this problem, which is a great problem to have, but there are some functions that are just too fast to accurately benchmark. And what we discovered is, so like when you use timer TC, which is at the sort of core of Benchee, which is the timer, it's basically like the benchmarking function built into Erlang. When you use that, it defaults to milliseconds, or as the, is it milliseconds? No, microseconds, as the count of how much time has elapsed. But on most architectures, you can actually get that count in nanoseconds, so that you can get another level lower of accuracy. But for some reason on Mac OS, that doesn't work as expected. And in other platforms, it's becoming a little bit of an issue. And I think it's a known issue in OTP too. But clocks are hard. Time is hard. Clocks are hard. That's why I'd really love to rely more on reductions than on wall time. But, another funny thing is I'm finding in the work that I was doing with reductions is the reduction count and wall time doesn't always line up. Sometimes a lower reduction count is a higher wall time. And I don't know really what to make of that, because I know that reductions are essentially constant, but Yeah, time is hard. Benchmarking is hard. That's why when you do proper benchmarking, that's why you should always benchmark with a library like Benchee and not just with like time or TC, is you need to get a big sample and you need to do statistical aggregation over that. Otherwise, you're just going to get all outliers because there are so many outliers, especially when you get down into the really, really fast functions. Trying to get a statistically valid sample set there is just really hard. The standard deviations get really high and it's just, yeah, it's a hard thing to do. And I hate that bug so much. I wish it would go away.
There's an Erlang tracker that was linked that is apparently resolved in OTP 22.2. So maybe.
Yeah, I don't have a Mac to try it out, but I hope someone fixes it. I have to see if I find someone with a Mac and see if we can find out if it actually works now. But that was, I didn't like that. But
one of us can check after this. Since I was the one that found it, maybe I can run my little test suite again.
Please do. Yeah, absolutely. We can close it. That would be awesome.
In the meantime, though, I have the second paragraph on the on the Benchee README is this bug, so that's exciting.
Yeah.
All right, so I guess let's swing into training before we close out. So we were snooping around a bit, and we saw that you were one of the mentors, I think is what Exorcism calls it, for the Elixir track. How did you get involved with that?
So I'm actually not a mentor. A mentor is a relatively new thing in Elixir. What I am is I'm one of the maintainers of the track. So the way Exorcism started was that you have all these sort of toy problems and you go through and you do them and you upload them to the site and you can read other people's solutions and leave comments and other people can read your solutions and leave comments. And I love this way of learning because typically when you're reading someone else's code, the first thing you need to do is try and figure out the problem that they're solving so that you understand the problem so that you can then understand the solution. But with this, you already know the problem because you've just solved it. So you're seeing a whole bunch of people solve the same problem that you just solved. So you can apply their solutions and the stuff like the way that they're solving that same problem. You can apply the learnings from that, I find way better. But now what they have are actual mentors, which are volunteers and people that will go through that generally know what they're doing in a language and they'll go through and they make sure that every solution that's pushed up to Exorcism gets one of these mentors looking at it and giving you feedback. And you can go through an entire track of a language. So there's this core track, which is usually somewhere around 15 exercises that start at hello world usually and end up as something as complicated as like a fourth compiler or, pretty serious problems at the end. And then there are all these sort of offshoots at each step. So after you do one of the core, you might unlock a couple other side problems as well if you want a little bit more exercise and experience or practice with some concept or some idea. And what I've done is sort of helped to a big part of being one of the maintainers of that track is just helping people that are coming in to make pull requests. So when people add new implementations for new problems, I don't think they're always adding new problems, and I don't think we have all of them up. I don't think any language does. If anyone does, it's probably JavaScript or Python. But people will come in and they'll add, they'll do all that they need to do to get a new problem up so that other learners can work on that problem as well. Basically, it involves writing a test suite and then writing an implementation that shows that their test suite is correct. Because when someone goes on Exorcism, you get a README that describes the problem, and then you get a test suite, and you can just go one by one through the tests, and that should hopefully guide you to an implementation. So you can sort of do the test-driven development, but having a test suite that's already written for you, which is awesome. It's one of the reasons I love Exorcism is because I like writing code in that fashion, having tests to guide my development, and they give you the test suite for free, which is great. So what I do is I help people trying to come in and make contributions, and then I also sort of provide guidance in the general structure of the track. So, which exercises should be in the core, which topics are important to someone learning Elixir, in which order should they be presented. So we're making sure that people have some idea of pattern matching before they move on to like structs, before they move on to at the very end. I make sure that there's at least one exercise that has some version of OTP in it because they should at least be exposed to that. Just the core parts of the language and part of what makes Elixir and the Beam in general unique, and making sure that learners are exposed at least a little bit to each one of those things over the course of the core track, and trying to make sure that that's always trying to work that a little bit better to get feedback from the learners and saying like, actually we hit this part and it was like really hard compared to the previous one. And so we're always trying to make that better. And we're actually in the process of launching a third version now. They launched version 2 last year, and now we're working on towards version 3, which will allow people to not have to clone stuff down to their server. So it'll be in the browser, which will be even better. So in the browser for all languages, which is like, I don't even know how they're going to do that for PSQL, because they have MIPS assembly on there, and like I don't know what they're going to do for all of those languages, but they're planning to put all those languages in the browser, and that's going to be a Herculean feat, but it's going to make it even easier for people to get up there and get working on it, which is going to be great.
We're going to close out here, but Eric, I want to give you a chance to ask any final questions before we do.
Yeah, I think let's finish up with what was something that you recently read or attended or watched online or wherever, and you thought it was a great learning experience.
Oh, you know what I loved was Miriam Pena's talk, I think I think she did it in San Francisco and Stockholm, Beam Extreme. That was a really great talk because it was benchmarking, which I like. A lot of it was like benchmarking, but it was also giving people the license to do the things that like everyone says you can't do or shouldn't do, which sometimes you have to do. Like you have to have a good reason to do it, and then you have to have the data to back it up. But you have to say like, we know we shouldn't do this, but this is really our bottleneck. And if we use the process dictionary, it's actually going to save us, like for them, 4 milliseconds makes a big deal. I mean, it probably saves them more than that, but like they're shaving milliseconds off of what the Beam can do. So they need to dig into all those weird corners. And there are sometimes people that have to do that too. And sharing both what they have learned in all of those weird corners of doing the things that people say you shouldn't do, sharing that is important because then that's out there, but it also gives people I think the freedom to explore when they see someone as sort of like well respected in the community as Miriam and someone who knows what they're doing like her. I mean, few people have the Erlang experience that she does when they see someone like her saying like, no, actually it's okay to do this. You just have to have a reason to do it and understand the trade-offs because it's always trade-offs. So I loved that talk. There are others too, but that's one that just jumps to my mind somewhat recently that I really liked.
Well, Devon, we are so glad to have had you on the show today. Before we let you go, do you have any final plugs or asks for the audience, social media, where to find your libraries, how to get involved and support you?
Cool. So on GitHub, I'm Devon Estes, and Twitter is probably one of the other good places. Devon C. Estes. Couldn't get my name on that one. It was a little too late. Those are the best places. Or if you go to devonestes.com, all my stuff is there. If anyone is interested in a testing training, I'm doing a training on testing at ElixirConf EU in April. So if people want to come to what will hopefully be sunny Warsaw by April and learn about testing from the beginning all the way through stateful property-based testing, we'll be doing a full day on that there. And yeah, I mean, I'm going to be in Krakow for Lambda days too, but it'll probably be that's in like 2 weeks. So I'm sure that'll be gone by the time this comes out, maybe. But yeah, that testing in April, it would be great if people, or the training in April on testing, if people want to come to that. I'm looking forward to it. It's been something I've been wanting to do for a while, so I'm really happy that I'm getting to do it now.
Awesome. And we'll put a link to it in the show notes. Devon, thank you so much for coming on the show. That's it for this episode of Elixir Wizards. Thank you again to Devon Estes and my co-host, Eric Ostrich. Once again, I'm Justice Epen. Elixir Wizards is a Smart Logic podcast. Here at Smart Logic, we're always looking to take on new projects, building web apps in Elixir, Rails, React, Kubernetes, mobile apps using React Native. We'd love to hear from you. If you have a project we could help you with, don't forget to like and subscribe on your favorite podcast player. Also, leave us reviews in the iTunes store. We love those reviews, guys. You can also find us on Instagram and Twitter and Facebook. Devon, you're actually a great Twitter follow, by the way. I just wanted to shout you out. I enjoy your Twitter quite a bit.
Thank you.
You can follow me on Twitter, Justice Epen. So add us on all of those. Eric, you're Eric Ostrich on Twitter, I believe.
Yep.
Join us again next week on Elixir Wizards for more Working with Elixir.